vertical axis. Now, the way I relate this, I have to say my distance d is a vector made of two parts. My dx, which is this is my dx, and added to that is my dy. Now, after d, I have the same for the velocities. So my initial velocity and my final velocity, they're also vectors. But I also have the x components of them, and I have the y components of them. Correct? Mm-hmm. Now, what is the final variable? We said there are 5 variables. We did 4 of them. What's the 5th one? Distance?
Acceleration.
Acceleration. My acceleration can also have 2 components. Y. Vector. Yes? Vector, 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 vector. Is this a vector? It's not a vector. That's the thing. So, my A also has an X component, and my A also has a Y component. So my AY is also a component. So for all of these, my initial velocity vector has 2 components. Initial velocity vector x plus initial velocity vector y. My final velocity vector also has 2 components. My final velocity vector x plus my final velocity vector y. And the last one. What's the last one?
Acceleration.
And? Continue, please.
It's also
Final acceleration.
consists of AI and
No.
oh, and AX and AY.
Get it? Now, because the full vector is these 2 components and they're on different axes, different dimensions, I have to do the x calculations here, the y calculations there. At the end, I take them, use vector addition to find the final vector. You understand? So, the only thing which I can use for both of these calculations they have in common is my time. Everything else, I have to first find the component, then work in the components to find everything that's happening on this section on the horizontal axis. What's the good thing? On the horizontal axis, usually they say there is no other force except gravity. Gravity is which way? Acting which way? Down. Which axis is that?
Vertical.
Vertical. What does that say for the horizontal component? What is the horizontal component of acceleration? So I'm just walking this way. What is it? 0, exactly. So if I'm just moving up and down,
0.
and my acceleration up and down is always 0. Unless I have any other force, only force of gravity will give me this. And that makes these calculations simple. The only equation I can use is Vx is my x distance over time. Now this x is actually, if it's starting from 0, it's x. But if it's like between 2 positions, it's delta x, delta t. Yes? This is basically the only thing I can use. Unless there's another force acting. Now here, it gets complicated. Why? Because now this is not 0. What is my AY equal to? 9.81 or 9.8. Make it simpler, meters per second squared. Now because of this, I can use how many equations? 4 equations. Equation 1 to equation 4. Of what? Kinematics. We do remember those equations, yes?
Yeah.
So, what we did yesterday, now we can apply. But because we have constant acceleration only on the y-axis, in the y dimension, we can only do it here. Here I have only this formula. Because there's no acceleration, acceleration is 0. Now, when does this break down? Whenever you see they say air resistance can be neglected, there is only one force acting. That means this is true. If they don't say air resistance can be neglected, you have a force here. Because air resistance will stop your horizontal motion. Okay. So, here we go. Now, what you see here is the path the ball will follow if you have a horizontal kick to the ball. I don't know if it's a ball, it's a cannon, whatever it is. If you just give it a horizontal motion this way, look at what the vectors are saying to you. So the vector in each case, look at this vector, is the same size as it's moving this way. So if I was just looking at it horizontally, my horizontal component is the same size. Now, what is different is that at every point, whenever I'm adding the horizontal vector in time is going forward, I'm now increasing my vertical component of the velocity, which goes from 0, you see the second arrow? It's getting larger and larger. Why is it getting larger? What does that show? If my velocity vector in the y direction is getting bigger, what does it show?
Due to free fall.
One at a time. He's saying acceleration. What do you say?
Free fall is when
Yes, free fall has what?
acceleration.
That's it. When we say free fall, that's what it means. You have an acceleration this way. Yes? Okay? Question.